Awesome. All right, starting off, we're going to take a look at our DMR. There were a few that we were tripped up on yesterday, so we are going to look at those and see how we can fix them. First one that kind of tripped us up was this one, and the words that were tripping us up were the words either, both, and neither. Okay, so let's talk about what those mean. Either means or. You have a choice. You will notice it says the word or. You can have this or you can have that. Okay, both means together. Neither means none of them. You don't get either one. Okay. One thing that I also think tripped you guys up is that if you can buy both, it means together. So you would add the 97 cents and the $1.29. Okay. So let's take a look at solving this here. Which of the items below can you buy with the money? I have $1, and then I have 5, 10, 15, 20, 25, 26, 27, 28, 29. So I have $1.29 here, okay? That is more than the top. So yes, I can buy the top. The candy is exactly that money, so I could buy that. I could not buy both. If I bought both, I would need $1.29 plus $0.97. And that's going to be more than $1.29. Okay, so a lot of you yesterday chose both, and I think you chose both because you thought, oh, I can get this or that. That's where you need this word either. Okay, either the candy or the top. You can buy one or the other. You cannot buy both. Any questions on that one? A lot of us missed it. Questions are great. They help us learn. Okay. Next up, choose all. You get it yet? All. You get it yet? All of the equations that this picture could represent. That means there's more than one. You need to hear it again. All of them that are correct, okay? A lot of you guys picked the first one and then you said, yay, I'm done. And then when I graded it, I said, no, they didn't read all, okay? And I got sad. All means it's a good clue that there's going to be more than one correct answer, okay? I noticed there are 4 groups. 1, 2, 3, 4. I noticed there are 3 flowers in each group. I noticed that there are 12 flowers altogether. 3, 6, 9, 12. So my numbers that I'm using are 3, 4, and 12. I got to think about how I'm going to use them though. This one right here says 3 groups of 4. This is 4 groups of 3. A lot of you chose that one. There are not 3 groups there. There are 4 groups. Group 1, group 2, group 3, group 4. 4 groups. Okay. Next one, 4 groups of 3. Group 1, group 2, group 3, group 4. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3 equals 12. Yay, yay, yay. Yay, yay, yay. Yay, yay, yay. 4 groups of 3 is correct. 3 plus 3 plus 3 equals 6. Come on, y'all. That's just bad math. 12 divided by 4 equals 3. There are 12 flowers. They are divided into 4 groups. There are 3 flowers in each group. So this is a yay. 9 plus 3 equals 12. That's good math. It's true, but there's no 9 in this picture. Gone. Okay. A lot of y'all chose this one and then you moved on and you got it wrong because you didn't choose what? all of the equations. All, okay? There's more than one. That's a very big hint. And now every time you see the word all, you're going to hear me going, ah, and you're going to get it done right. And I'm going to be happy. So my must worked. Sometimes you
get the point.
Right. I'm glad that you get the point, Terrence. I can't wait to see you guys get the point on DMR today. All right, here we go. Fill in the box with the fraction represented by the number line. People, if I see y'all count the lines on a number line one more time, I'm going to invent a way to come through this camera and scream. That's what I'm going to do. Okay? Do not count the lines on a number line. You count the spaces. For the same reason when you get a cake and you chop it up into pieces, you don't point to the crack where the knife is and say, I want that. No, you point to the space that is the cake, the piece between the lines. Okay? Please don't make me invent things. I don't have time to do it, okay? But now that I said it, I'm going to have to do it. Don't make me invent something to come through the camera and scream at you. Don't count the lines. Count the spaces. Here we go. I have from 0 to 1. Take a look. 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces, 6 spaces. My numerator is at 6 spaces. Now I got to keep going with my denominator. 1 space, 2 space, 3 space, 4 space, 5 space, 6 space, 7 space, 8 space. 6 eighths. 6 eighths right here. Some of y'all said 7/9 because you counted the lines. So next time you're at school and we have a pizza party and you say, can I have a piece? I'm going to say, yeah. And I'm going to grab the crumb that's in the crack where I cut the pizza and I'm going to put it on your plate because that's what y'all are counting when you count lines. Okay? No, you count the space in between, the piece. Okay? The piece. All right? That space. 6 eighths. Okay? All right. Compare the models. Choose the symbol that makes the comparison true. You guys did great on this one. Your comparison symbol was the less than because 1/4 is less than 2/4. Okay? So it should have gone that way to eat the 2/4. Nice job on that one. Y'all did good on this one too. 284. Notice I said 4 when I went to the 4. See how I say the answer if I say the number 284. It's right there. The value of a 4 in the ones place is 4. William, yes, sir.
Can I share my screen to show you? Because can I share my screen?
To show me what?
DMR.
Okay, I'm scared. I'm nervous.
What is you disabled it?
Go ahead. I changed it. Also, I like that you put in the chat yellow. Yellow. I have a question. That is not DMR.
I know. Something else. This. Look.
Yes, you checked 3 times 4 and 9 plus 3 equals 12. Those are correct, but those don't match the picture. There's not a group of 9 flowers plus 3 flowers. And then 3 times 4, that would be if there were 3 groups with 4 flowers. But
it says, how is there only 2 answers? It says choose all of the equations. Those are all equations.
That this picture could represent. Only that are true for that picture. You got to read the full directions, Bubba. Dun, dun, dun. You taught us a valuable lesson today, though. You taught us to read our directions completely. So thank you for that valuable lesson. All right, here we go. Next one says round this number. When we round numbers, we have lots of strategies. The rounding roller coaster, the rounding rhyme, a number line, benchmark numbers. Let's take a look at benchmark numbers today. We're going to round this digit right here. So the 4. 4 or less gives it a rest. So this is either going to be 280 280 or 290? It's a 4. It goes down to 280. Boom. Okay. All right, folks, that's your DMR. Remember 2 things. I'm not going to put you through them again because I think I made the point clear and Terrence said y'all got it. But I'm going to get more dramatic tomorrow if you didn't get it on DMR.
No.
So just be ready for that.
No.
All righty, folks, here we go. Switching gears, we are going to take a look at comparing fractions with the same denominator. Levin has a question about math before we begin.
Do you? Never mind.
All right, here we go. Let's take a look at your seesaw over here. You need to click on the activities to refresh your feed if you have not done so yet. And we're going to take a look at compare fractions, same denominator. Okay, this is our last day looking at fractions that have the same denominator. Tomorrow we're going to switch to fractions that have the same numerator. Okay, so same denominator. It says with your teacher, view the example videos and then show your work on slides 1 through 4. Okay, so go ahead and click on that add response, please. As you are pulling up your response, I'm going to play our success criteria so that you are reminded of what your goal is.
Our learning target today is to compare 2 fractions with the same denominator by reasoning about the size based on the same whole. So today we're going to look at 2 fractions and we're going to compare them. Our fractions will have the same denominator. For example, 3. We will compare these 2 fractions using our comparison symbols. Our symbols are greater than, less than, or equal to. Today we will compare these fractions by representing the fractions using models.
All right, so we're going to look at models today. The models that we're going to be looking at today are the circle model and the rectangular model. On video 2, slide 2 of the instructional video is a YouTube link to a video that you can watch if you are working independently and are feeling confused, okay? So this is an example that you can come back to when it is independent work time, all right? Okay, for right now, you guys are on slide 1. I am going to play this example. You do not need to play this example because then you'll have 2 sounds at one time. So here is our example video, and then we will solve one. So we're going to look at how to partition and compare a rectangular model. And then on slide 2, we are going to partition and compare a rectangular model. All right. All righty then.
Today we are going to compare 2 fractions with the same denominator by representing these fractions using a model. Our task tells us to compare 2 1/3 and 1 1/3. So notice that I have 2 models because I'm going to show one fraction here and another fraction here. Notice also that my 2 fraction models are the same size. When we compare fractions, it's really important that we are comparing fractions that have the same size whole. Today, I'm going to show you an example of how we can use a shape to partition, shade, and compare 2 fractions. Our task says compare 2/3 and 1/3. I notice that my denominator for each is the same, and it is 3 because I am partitioning into thirds. Next, I can partition each model into 3 equal parts. I have now partitioned both models into thirds, or 3 equal parts. On the left side of my screen, I'm going to represent and show 2 1/3. Remember that each part is called the unit fraction. Each one of these parts is 1/3. So if I'm going to represent 2/3, that means I can shade 2 1/3. 1 1/3 plus another 1/3 and when I add those together, we know that 1/3, whoa, let's try that again. 1/3 plus 1/3 is the same thing as 2 1/3. On the left side, I have now represented 2/3 or 2 1/3. Now let's look on the right side of our screen. My task asks me to compare 2/3 and 1/3. Remember that each part of the fraction is a unit fraction. And on the right, I'm only going to count one of the parts because my fraction says 1/3. So I can shade 1/3. There we go. And I have now represented 1/3 using my model. Now comes the job where we compare using greater than, less than, or equal to by looking at the models. I notice that on the left side of my screen, I have 2 parts that are counted or shaded. I also know that because my numerator tells me how many parts I'm counting. On the right side, where I've represented 1/3, I only have 1 part counted or shaded. This is how I know that 2/3 is greater than 1/3. So now I'm going to select my correct symbol. 2/3 is greater than 1/3.
All right. A lot of you have told me, Miss Sousa, I get it. Okay, I get it. And you're right, you do get it. But your world is getting ready to change tomorrow when those denominators are different. So we want to make sure that you understand the process of how to make that decision. Okay, so we're practicing the process today. A few of you just joined us. Welcome back. Thank you for doing your best on your WIDA testing today. If you are just joining us, you are right in time. You're going to go to Seesaw, click on your activities, and we just watched the video on slide 1 of compare fractions, same denominator. So you are in perfect time. We're getting ready to work on slide 2 together, and that's the first thing that we're gonna do together, okay? So slide 2. All right, compare 6/8 and 3/8. Let's go ahead and grab that highlighter tool and highlight that we're working with 8ths. 8ths have 8 pieces. So we're going to turn this rectangle into 8 pieces. When I'm drawing with my pen, sometimes my mouse gets a little shaky and it looks like this, and that's a hot mess. So I like to use the shapes tool and grab this rectangle and use that to create a straight line. That way, if I put it somewhere that I don't like, I don't have to click the eraser. I can just drag it where I want it. So I'm going to ask that you do the same thing. I'm also going to ask that you partition these the same way that I do. I do know that there is more than one way to create an 8th, but for visual ease, I'm going to ask that you do it the same way, okay? So I've got an 8th. I grabbed a shapes tool. I made a line straight across. I'm going to duplicate this and put it over here as well, because both of these have 8ths, right? So whatever we do on the left needs to be done on the right. I'm going to duplicate this again And then I'm going to turn it on its side so that it creates a plus sign. And I'm going to shrink it by putting it in the middle and making it as tall as the rectangle. Okay, it looks like that left side's a little bit smaller, so I'm going to move it over. So much easier than having to erase. All right, duplicate it. Do the same thing over here. And I'm going to pause right there and give you a moment to get caught up. So I'm going to turn that so it's a little more straight. There we go. So far we have fourths. We have to create eighths. Taking a look at your screen. Terrence, I'll need you to fix that one. It looks like you went ahead and got some mistakes on there. So go ahead and do what we are doing here. Josh, we're on slide 2, baby. All right, good. You have your fourths. Now we know that 8 is double of 4. So I'm going to take these pieces and cut them in half, okay? I'm going to duplicate this shorter stick and put one on the left and duplicate it and put one on the right. And there we go. I've got 8 pieces, 4 on top, 4 on bottom. Now I'm going to do the exact same thing over here. I'm going to duplicate, cut the pieces on the left in half, duplicate, cut the pieces on the right in half. And I've got the same thing, 4 on top, 4 on bottom. Okay? 8 and G.
The screen is all green.
Your screen or my screen?
Your screen or my screen? The sharing screen that you're doing right now.
Oh, is it green for anybody else?
No.
No, strange, Jaden. You might have messed with your color settings. All right. Okay, very good. Now we have to shade 6/8 and 3/8. So I'm going to go ahead and highlight that this is 6, and I'm going to shade over here on the left side 6 of these pieces. And remember, I'm shading the pieces, not the lines, right? Not the cut marks, the partitions, the pieces. 1, 2, 3, 4, 5, and 6. Okay. So over here, I have 6/8. That fraction has been partitioned and shaded. 6/8 is done. Over here, I am asked to highlight 3/8. 1, a 2, a 3, and that's it, 3/8. I want you to also notice that I am shading in the same locations. I'm not skipping around and doing a piece on top and a piece over here on the bottom and then a piece in that corner, because then my brain has to take those pieces and move them together and see which one is bigger or smaller. That's a lot for my brain. So I make it easier and just have it right in front of me visually. Okay? Looking at this, we know that these pieces are the same size. These are 1/8 pieces, and this rectangle is the same size as these 1/8 pieces in this rectangle. So I know that when I'm comparing with the same denominator, whichever fraction has a higher numerator is going to be the greater fraction. I can also see that visually there is more colored on this side of 6/8 than there are on this side of 3/8. So 6/8 is greater than 3/8. We are asked to type or voice record. I'm going to choose typing so that you don't hear my voice in your voice recordings. And I'm going to explain how I know. 6 1/8 pieces. Taking a look at your screens, you are on slide 2 with me. You should be typing and adding that text box. Six 1/8 pieces is more than 3 1/8 pieces. 6 1/8 pieces is more than 3 1/8 pieces. That is an explanation of how we know. Kiddos, I am seeing a lot of people that are jumping ahead and doing the independent work. I am also seeing those same people doing the work incorrectly and those same people forgetting to put the explanations. It does not help you to rush ahead and do the work wrong because you don't know what I expect. Please stay with us, okay? I am not teaching because you guys have rocked it and you're amazing and I want to make you bored. I'm teaching because I'm still seeing some mistakes. I'm still not seeing the correct vocabulary being used. So stay with me, please. Alrighty, are there questions about this slide, about why we solved it the way that we did? Frank, remember, I'm writing and you're writing. Looks like you're taking a look at TV right now. All right, let's go ahead and take a look at your next slide. This is a video. This is how we solve a circle model. Okay, we're going to partition and divide a circle model now.
So how do we compare fractions with the same denominator? Let's do some examples together. Compare 3/4 and 2/4. First, I'm going to create a model. Here I have 2 circle models, and notice that they are the same size. When we are comparing fractions with the same denominator, we have to make sure that the one whole size is the same for both models. In this circle model, I have made sure that both one wholes are equal in size. Next, I'm going to look at the fractions I'm given. My problem tells me to compare 3/4 and 2/4. So first, I need to look at what my denominator is, even if my fraction is written in word form. I notice that they are asking me to compare fourths or 1/4. So my next job is to partition my model into 4 equal parts. I now am showing you that each model has 4 equal parts. When all of the parts come together, we know that is equivalent to one whole. I have labeled each part with my unit fraction. 1/4, 1/4, 1/4, 1/4. I've done the same thing on this model to represent I'm partitioning my model into 1/4. Next, I can shade and count up my unit fractions to represent the given fraction. So let's take a look at that. I'm going to compare 3/4 or 3 1/4. Notice that I have shaded 3 parts on the left model. 1, 2, 3. 3 of my 1/4 parts are shaded red. We know that's the same as saying 1/4 plus 1/4 plus 1/4. When we combine these unit fractions together, we get a new fraction called 3 1/4. I'm going to represent using a model, and then I'm going to label this fraction using my fraction bar here. I'm going to record that I have represented 3 1/4 on the left side of my seesaw task. Next, I'm going to look at my other fraction given to me in the problem. It says to compare 3/4 and 2/4. Notice that I have partitioned this shape on the right side into 4 equal parts. And to shade 2/4, I had to add 1/4 plus 1/4. When we combine those 1/4, we get 2 1/4 or 2/4. I can record my fraction using my fraction bar on my seesaw task. I have now represented 3/4 using a model and 2/4 using a model. And now I get to compare and think about which fraction has more area shaded. Well, I also notice when I added all my unit fractions together, on the red model, I added an extra 1/4 piece. There are 3 red parts on the left, but on the right, there's only 2 parts shaded. So 3/4 is greater than 2/4.
All right, so let's take a look at doing a circle model together. You're on slide 4. Slide 4 says compare 1/3 to 2/3. Okay, so we know that we have to create thirds. All right, I like again to create mine with these lines because it's easier for me than having to erase if I make a mistake. So I'm going to create a first line and drag it to the middle of the circle. So from the top edge to the middle. And then I'm going to duplicate it and do the same thing on the other side because we know that both of these have to be thirds. Okay. Now I'm going to duplicate this and I'm going to put it in the middle, but I'm going to turn it. Boop. So it's going to make an upside down Y. A little more turn. There we go. I'll drag it to the edge and I will duplicate it and put it in the exact same place over here. If you duplicate it while it's turned, you don't have to turn it again for the second model. Work smarter, not harder, y'all. And then I'm going to make one final one to make that other side of my Y. And again, I'll turn it. And then if I duplicate it when it's already in its place, I don't have to turn it again over here. It's already turned for me. There we go. So I now have thirds. This fraction says 1/3. So I'm going to choose one piece and I'm going to shade that one piece. And that gives me 1/3. Next, we have 2/3. So I need to highlight 2 pieces of my thirds. 1, and again, I start highlighting in the same place so that I don't have to imagine moving it in my mind. I can just see looking at it visually. And here's a second one. All right, so that picks us up here, and you have 2/3. Now we can tell by looking visually that 2/3 has more that is shaded, and we can also see by our numerator that there are more thirds with 2/3 than there are with 1/3. So this will read 1/3 is less than 2/3. Seeing a lot of you on your screen have already done the explanation. I appreciate you being responsible with your learning. If you need help with the explanation, here it is. 2 1/3 pieces is more than 1 1/3 piece. 2 1/3 pieces is more than 1 1/3 piece. Any questions on that one? Ready? Move this microphone up. Somebody said it's a little bit more difficult to hear. There we go. All right. Your independent work today can be found on slides 6 through 9. So that is 4 problems, okay? Slide 5 has your instructions. It says, 1, read the problem. 2, partition the shapes to represent each fraction. And 3, compare using less than, greater than, or equal to. So you're doing exactly like we did together. You will complete slide 6. Don't forget to explain how you know. You will complete slide 7. Don't forget to explain how you know. You will complete slide 8. Don't forget to explain how you know. And you will complete slide 9. Don't forget to explain how you know. On slide 10, this is your success criteria. Let me know how you're feeling about your goal today of partitioning and comparing fractions with the same denominator. And remember to explain how you feel using math vocabulary words. On slide 11 is a link to a tool that you can explore with creating fractions. And if you'd like to share what you noticed, feel free to do so on this slide. Okay, that is your task for today.